by saying more about the topic. I do not want to take more time. Rather, it would be better to hear from our honorable speaker. But before that, I must invite our respected Vice Principal, Dr. Sandip Kumar Ghatak sir, to deliver his speech regarding today's program. Please, sir.
Am I audible?
Yes, sir. Yes, sir.
Am I audible?
Yes, sir. Yes, sir.
Okay, thank you. Thank you, Kakuli. Very warm welcome to all honorable delegates, my dear students, my colleagues for this webinar organized by the Department of Physics in collaboration with the IQAC of Asansol Girls College on Gravitational Wave, the Song of Cosmos. At the outset, I convey my gratitude and thanks to our speaker, Professor Soumitra Sengupta. In fact, my background is different. I'm not coming from either science or more particularly from physics background. So I believe, in fact, we have no idea about this particular topic, in spite of the fact from the topic and the initial speech of my colleague, Dr. Coulomb, I believe that the webinar will be very excellent and very relevant, and those participating this webinar, they highly benefited, I think, from this webinar and from the speech of Professor Soumitra Sengupta. I also convey my thanks to the Department of Physics who organizes this webinar. So without wasting much time, I hand over to my microphone to Kakoli Bandopadzhay so that they can start their webinar at an earliest. Thank you, Kakoli.
Thank you, sir. Let me now say a few words by way of introduction of our speaker, Professor Soumitra Sengupta sir. Professor Sengupta is a very renowned researcher in the field of theoretical physics. Currently, he is having two positions: Amol Kumar Rai Chaudhuri Chair, Professor in the School of Physical Sciences, Indian Association for the Cultivation of Science, Kolkata, and he is also the chair of the School of Mathematical and Computational Sciences, SMCS, IACS, that is Indian Association of Cultivation of Science. He has more than 120 papers in reputed international journals. Not only as a researcher, he is very much popular among his students and a renowned speaker in various fields of theoretical physics. He is a fellow of the National Academy of Sciences, India. His field of expertise are cosmology and black holes, brain world phenomenology, extra-dimensional theories, supersymmetry and supergravity, string theory, etc. I now invite Professor Sengupta sir for his valuable speech, for which all of us are eagerly waiting here. Sir, please.
Thank you, Professor Bandopadzhay and Professor Ghatak. I sincerely thank all of you for inviting me here in this very special seminar. I know that I have many young students, and I'm really thankful that for giving me this opportunity to speak in a platform, but so many young future scientists are there. So, and I know that this college and also the college from the other colleges from where the students have come, they actually are the sources from where we get such good students in our institutions. And my objective is that so that in future I will find many of you joining research in this field. And the whole objective of myself is to share some of my excitement in the area of research where I do research personally, and along with my gravitation group in my institution. And primarily, I would like to tell you that there are so many work which gets Nobel Prize every year, in fact. But why some of the work are very special? And this particular work created absolute sensation all over the world. And I will explain why. And I will definitely take your questions. Whatever question comes to your mind, please ask me without hesitation. I will definitely try to answer your question. And you can stop me anytime if you want to, if you have any question. And of course, at the end, I will ask you, I will take your questions. So now I'll be sharing my screen, and please let me know whether you can see this. I'm sure you'll be able to see this. So is the screen visible to all of you?
Yes, sir.
Okay. Right. And I'm entering full screen. Now it is better.
Yes.
I hope you can see the full screen.
Yes, sir.
Okay.
Yes.
So, and I hope I am audible also clearly. So everything is all right. So video and audio, then I will start the talk. Everything is okay. Can anyone of you respond that the video is all right and audio is all right?
Yes, sir.
Okay,
Yes, sir.
great.
Yes, sir.
So as you can see, the title Gravitational Wave, the Song of the Cosmos. So I'm from an institution which is located, it's an under central government institution, under Department of Science and Technology. See, originally it was a research institution, but now it's deemed to be a university. We give our own degree. So it's essentially a central university on the city of Calcutta. And we have both undergraduate and postgraduate program. We have BS program also, and also the master's program, and of course the PhD program. So this is, with this introduction, let me start about the main topic of the work of today's discussion. So a magical moments, 14th September 2015, for the first time we have heard the musical voice of the cosmos. And then again on 26th December 2015, and then again few more times. And in this process, we detected gravitational wave. So this gravitational wave is our musical voice, and I'll tell you why this has created so much of sensation all over the world. So the Nobel Prize for this discovery was awarded in 2016 Nobel Prize in Physics to these three people, Rainer Weiss, Barry Barish, and Kip Thorne from MIT, Caltech, and of course the other one is Caltech. Originally, he did his PhD in Princeton. So they are great scientists, and this was a great work, of course. And this was, I mean, it's a very long cherished dream, but you need to know the dream actually started with somebody else. And these people eventually, I mean, fulfilled those dreams. The story begins with Einstein. All of you know about this almost magical person of science who changed the course of science, the direction of science on many occasions. And he will, of course, I mean, we have to I've set the stage with Einstein, that what he did actually. And he is a person who created new direction in physics. And without Einstein, this talk is incomplete because this is his dream. And so the first few slides will be dedicated to his work and what led to gravitational wave. I repeat that you can ask me question anytime and in any language, English or Bengali, you are just feel free and ask me. We all know that our universe started with a huge explosion, Big Bang, many, many years before, unquestionably, but not infinite. It's a very finite time before. So finite time before, maybe very billion and billion years, but still it's a finite time when universe was a point which exploded with a Big Bang. This is now established, and it started expanding ever again. And all these stars and galaxies that were formed, the collection of stars, universe is expanding and galaxies are going away from each other. They are expanding in size since the birth. As you can see, at the time of the birth, the universe had a huge expansion called inflation, and the temperature, the energy and temperature, of course, heat energy, temperature was very high, 10 to the power 13 Kelvin, and gradually temperature reduced as it expanded, and various particles, matters, everything formed slowly, and then the stars, planets, and etc. And finally, today, we are sitting here now, and we have this history of the growth of the universe. This is again the same story, but this is in terms of time at different, when what happened. After 1 second, this happened. After 3 minutes, so and so. Many particles were created very shortly, quickly. But then it took quite some time, 300,000 years, to form these kind of structures. And then gradually we are here today. Now, just to give you an idea, the galaxies are nothing but the collection of many stars. So universe, it's a collection of many stars. Then there is empty vacuum. Then again collection of stars. Then again it's a vacuum. So each such collection of stars are called galaxies. And just to give you an idea, just each galaxy approximately on average contains 10,000 crore stars. Remember, sun is just one star. And each galaxy contains approximately 10,000 crore stars. And with size, if you consider this cluster, this collection of stars, roughly this kind of shape, the diameter of this is approximately 18 zeros after 1 kilometer, roughly. So this, you can imagine, the sun is just one star and we are just one planet, but there are 10,000 crore stars in our own galaxy, which is Milky Way, with this size. And now, so far we have discovered about 10,000 crore galaxies, each containing that number of stars. And the average distance between two galaxies are 10 to the power 20, that is 2001 kilometers. So can you imagine that Earth is not even a point? Earth is nothing in this universe. But still sitting on that Earth, in the last 300 years of the development of modern science, maybe 400 years, we have discovered so many things. This is certainly one of the most ambitious things, science, in comparison to anything else. But at the same time, so many things are yet to be discovered, and which I'm sure some of you will be doing. So in this huge size of the universe, we are sitting not even at a point, we are trying to understand the universe. The question is, one very important question is, how do you know this? Suppose we know that there is a star there, there is a planet there, and so many things. Not even that, if you are somebody staying in US, you are seeing the cricket match, Olympic every day. So many things, we are receiving information and giving information to and from one place. So our knowledge depends only on this. That is how to communicate. How do you see an Olympic match? How do you know that star is there? How do you know? What is the way to communicate? When you talk over phone, how do you do that? And you'll be surprised to know that the only mode of communication is electric and magnetic field. There is no other mode of communication. So how do you do that with electric and magnetic field? Newton taught us that, all of you have studied from your school days, force is mass into acceleration. That is, if you apply force, then only a mass will accelerate, given by this equation. And not accelerating means remaining static or moving in uniform motion. So that's most uninteresting thing. All interesting things are acceleration, and acceleration means force. So force is the cause of all interesting things. And we know there are two main forces in nature. One is electric and magnetic force together called electromagnetism, and the other is gravitation. Every force that you see has its origin because of electric and magnetic force, because of electric charges. So you may say, I am pushing something by my hand. What happens is that the electric charges on the atom in your skin, suppose in your hand there are atoms, right? Everything, our body is comprised of atoms. Atoms have electric charges. That electric charges, suppose you're pushing say some big, something, some table, and the table will also have electric charges because it has atom. And those two atoms, they repel each other and the table move in one direction. So when you are pushing something, pulling something, doing anything, those are all happening because of electric charges in your hand or everywhere. And that electric charges are repelling each other and it is experiencing force. The other force is gravitation, the force between two masses which attract each other, all of you have heard. That has got nothing to do with electric charge. It happens because of the masses. So everything that you see around you are largely, you can account for by only these two kind of forces. So you can say that these two forces are governing our life. You cannot imagine if there is no electric charge and if there is no gravitational force between masses. I can explain that there will be no life in the universe. So these are such important forces. Now, the first one, electric magnetic force, everything was discovered by three people, Coulomb, Faraday, and Maxwell. You have heard about their name. They're great scientists who actually finally established everything about electric and magnetic forces. What did they do? You all know. Coulomb said electric charge causes electric force. Suppose you have a plus charge, minus charge, they attract. Two same charge repel. You are hearing this from your school days. And there is electric lines of force, they attract or repel. So this you know. So two static charges, if this charge is static, they are just moving, they are not moving, they are static, and they apply electric force because of the electric charge. But if a charge moves, suppose a charge moves with velocity v, then moving charge is called electric current. So current means moving charge. And that produces a new force around it called magnetic field. So if there is another charge moving, it produces a magnetic field, and two magnetic fields, they exert force on each other. So for this reason, so you may say, I have a bar magnet. Who is moving? The moving is the electrons inside the atoms of the bar magnet that is moving and causing that magnetic field. The motion of the electric charge causes a new field. Electric field is there, the original electric field, but also you have now a new field called magnetic field. So this produces magnetic force, moving charge or electric current. These electric field and yes, please.
Can I ask something?
Sure.
So in Coulomb's law, we know he proved it by torsion balance. So
Yeah.
sir, how he given the certain amount of charge to the two balls?
Okay,
How can he measure that there are certain amount of charge?
So see, there is certain amount of charge means what you can do, that suppose you do a rubbing. So these are, the experiments are done in a very approximate way. The greatest of scientists can get the idea from that. So suppose you produce a rub an object and it gets charged. Rubbing produces electric charge. So you rub another object, it produces electric charge, maybe slightly different. But if your rubbing is more or less similar on the same object, in the same condition, it produces equal charge roughly. Now what you do, take two such similar objects, do the rubbing and put them closed. So they now have charge, which was original, get twice of that. So what he did, he found the unit of charge is something, and it produces double, triple, or fourth time of that. And in that process, it put those charges in a torsion balance and found the forces. So I will tell you details later, but do you know electric, when you do experiments, you cannot produce exactly 5 units of charge, but you can produce a similar condition whereby, assuming that by similar condition 5 and 5, it makes it 10. So we'll suppose even it makes it 11, it doesn't matter. I can calculate the force, and I can estimate from there by statistical calculation that what is roughly how the force is changing as the charge is increasing. So these are details of the experiment. I don't have time to tell you, but it was done.
Okay, sir.
So these electric field E and magnetic field B are described by Coulomb's law and Faraday's law. You may have read this in your book, and they are combined by Maxwell, called Maxwell's laws, which tells everything about it. But then that shows, these laws also show that when the electric charges accelerate. Now, I was telling about motion, but motion means can be uniform velocity, right? But now, suppose the velocity is not uniform, velocity is accelerating. Suppose the charge accelerates, then something funny happens. When the charge accelerates, then the electric and magnetic field that was there start to travel in space. So this electric and magnetic field, which was there, either this, they start to move in space. So they start traveling in space. The field itself starts moving. So you didn't have electric and magnetic field here, then next time, after some time, the charge is accelerating at a long distance, that electric and magnetic field gradually comes here. And that electrical magnet starts to travel in space, called electromagnetic wave. So electromagnetic wave is nothing but the moving electric and magnetic field because of the charge and electric charge which accelerates. Now, this is the wave equation. I mean, if you haven't seen this, please believe me that if phi is the electric and magnetic field, roughly, an equation of a wave is given by this, where v is the velocity of the wave. Now, Maxwell, Faraday, they showed from that equations that electric and magnetic field satisfies this equation, which is same as this, where this is showing that the speed of the electromagnetic radiation, the velocity, is nothing but the speed of light. So they concluded that light is nothing but, the light which you observe is nothing but electric and magnetic field, which moves. And so how it moves, this electric charge which oscillates, suppose which accelerates, suppose it's accelerating here, but the electric and magnetic field, see, they are moving like a wave. And this, but they are mutually perpendicular. So if electric and magnetic field oscillates like this, the magnetic field oscillates in the perpendicular direction. So is it the problem for everybody? Nobody can see this? Can you see this?
Yes, sir, we can see this.
Yes,
You
sir.
can see
Yes,
this.
sir, very clear.
Okay, fine.
Very clear. So the varying magnetic field is not showing. It is showing only the scientist's page.
No, you can see one pink E0 which is oscillating,
No,
and the
sir.
other, huh?
No, sir, pardon me. There is no such equation showing.
No, there is no equation. It's a diagram.
No, sir,
Okay.
no diagram is there. Only the first page is there, electric magnetic force by Coulomb, Faraday and Maxwell.
Electric and magnetic force by Coulomb, Faraday and Maxwell.
No, sir, I am for me
Sir,
it is
showing the
visible.
three scientists
All the slides.
together, only the thing is showing.
But I am changing the slide here. I mean,
your device problem, because it is seen clearly and it is also audible.
if a single person can see this, then that means it is transmitting from my side. So can you please check your internet connection? It got locked at some point.
So everything is perfect, sir. Please go ahead, sir.
Perfect. Okay, so this is the electric field which is oscillating, and this is the magnetic field which is oscillating perpendicular direction, and they are moving towards this direction, propagation direction. Now, so this is the same thing. Oscillating electric and magnetic field is blue, this is red, and electric field is red, and this is the direction of travel. They are perpendicular, and since it is moving in the perpendicular direction and field oscillates in this plane and motion along this is called transverse wave, because in the transverse plane, and the distance between the 2 points which are in the same phase called wavelength. So what we learned, light, X-ray, everything are electromagnetic wave, whatever see of different frequencies. Electromagnetic wave, you know, X-ray, electromagnetic wave of very high frequency, light is lesser, infrared is even less, gamma ray is very large frequency. So the frequency are changing. Frequency means how quickly the electric and magnetic field are oscillating and moving. So that is called frequency. And but all of them travel in empty space in vacuum with speed of light, which is very large speed. And now I tell you that this is our only mode of communication in the modern world. Why? Because there is a antenna, suppose, which, so this is something which is your, you suppose you are speaking in your mobile phone, and that mobile phone has some oscillating, when you talk, your sound energy converts into oscillating energy of electric and magnetic field, which is transmitted to transmitting station for your service provider. It is then travel through a wave, as you can see, and here it's somebody sitting with a mobile, so it can be mobile, it can be some, if you're picking up a photograph of the Olympic ground, some event, and that photograph is sent, and it goes and is sent via satellite in the sky, because it cannot go straight. Earth is curved, so if you electromagnetic wave goes straight, it will escape. So if you send from this part of the Earth, the other part will not receive it. So we send it to upward direction to a satellite. The satellite send it to the respective countries. But all are electromagnetic wave, and it is our only mode of communication. So when you are seeing a star in the sky, it is emitting light. That light is coming to your eyes. It is electromagnetic waves. The only way of our exchange of knowledge is electromagnetic wave. And you will be surprised to know that this was done first in our city by Sir J.C. Bose. Such an absurdly important discovery. I believe that it should be given 3 Nobel Prize. The whole modern civilization dependent. But all of you know that sad story. The J.C. Bose was wrongfully deprived and was not awarded the prize. And much later, in the beginning of this century, some scientists in the United States, they have finally proved by looking into the documents with Royal Society that it was J.C. Bose first who actually did it. First time transmission of electromagnetic wave communicating a signal from one point to another, from University Institute Hall to the laboratory of Presidency College. This wave was transmitted first time, and that is now ruling the whole world. I feel sad that we don't remember our real heroes. So it's a great discovery by J.C. Bose. This mode of communication originated from electric and magnetic force, as I said. But you know that there is another force. So an inevitable question that comes, a vital question, what happens for gravitational force? Does gravitational field also travel like a wave with a finite speed? And can it be another possible mode of communication? And as you understand, this is such an important question. Now, what do you know about gravitation? Sir Isaac Newton, all of you know this story, that asked this question, why apple is falling, because the earth has a mass which is attracting this mass of the apple towards it. All masses attract each other. So he discovered the force of gravitation. But he was such a great genius that he also could understand the same force is responsible for the motion of the planet around the sun. And he explained the planetary motion around the sun by his famous equation. And he showed that sun is attracting the planets and it has some velocity, so it is moving in a bound orbit around the sun following the laws of gravitation by Newton. And what was that law? That law says that if you have a mass m here and small mass m here, distance is x, then the force between them is given by product of the two masses and 1 by the square of the distance between them, which means as the distance increases, the force is reduced, and the mass increases, the force is increased. Now, this G, the constant of proportionality called Newton's constant, this is a constant quantity, has such a small value that unless one of the masses are very large, this force is very weak because of the value of G. So now you imagine that because of such a small value of the Newton's constant, you have kept two bottles on your table. So one bottle, another bottle. Do you see the two bottles you have kept on your table and the two bottles are coming towards each other? You never see that. Why? They are attracting by this law, but the force of attraction is so small because G is small that it cannot overcome. The force of attraction is there, but the frictional force on the table, which is basically an electromagnetic force at the contact, there are electric charges, they stop the motion. So they don't come. But if one of the mass is large, suppose Earth, the other is an apple, then the force is large. Then it goes down. If both the masses are large, one is planet and the other is sun, then also it moves. The gravitation becomes important for large masses. And large masses we encounter in the sky. So for astrophysics, the gravitation is the most important force to study. But our daily life on our table, the gravitation is there but very weak in comparison to electric force. So according to Newton, the speed of propagation of gravity, okay, so Newton said that, see, suppose you move this mass from here to here slightly, then immediately the gravitation force gmm by x squared, x changes and immediately the force changes. That is, its motion is sensed by this mass, the force gets reduced immediately. That is, its motion here, earlier the electric charge has the electric field around it which was traveling with speed of light, very large speed but finite. But here it is saying that the moment you move it, immediately, instantly the gravitation effect is transmitted. That is the statement is, according to Newton, the speed of propagation of gravitational effect is infinity, instantly it propagates instantaneously. If mass m moves, gravitational field at a point changes immediately, instantly. So as if the field is changing immediately, that is traveling with an infinite speed. Well, you may think that is good. It is going from one point to another so fast, but then there is a problem. The problem is because of a strange observation. You just follow what I'm saying. Suppose there is an object here, there is an object here, and this object is A, this object is B, and this is traveling with velocity v1 with respect to the static observer, and this object is traveling toward this direction v2 with respect to the static observer. This means with respect to this observer, this is traveling a distance v1 in 1 second, this is traveling a distance v2 in 1 second. Suppose I ask you, what is the speed of B as sensed by this observer, moving observer? So what is the relative velocity? Velocity of B as measured by A is what? You will say, this has traveled distance v1, this has traveled the distance v2 in 1 second. Distance between them has been reduced by v1 plus v2. So he will say that B is moving towards him with speed v1 plus v2. All of you know that in a moving train, another train coming from opposite direction, it appears to moving at a very high speed. So relative velocity is equal to v1 plus v2. This is the prediction of Newton's law. And that is understandable. We have all studied in your class 12 level, the relative velocity. But the problem is, suppose one is moving with v1 and the other is light. So this observer is saying this is traveling with speed c. C means, 3 into 10 to the power 8 meter per second. And this is traveling a distance v1 in 1 second. I ask you what is the speed of light as sensed by this person. And you will immediately say it will be v1 plus c because speed is v2 is c. So if b travels to speed of light, c with respect to the observer, the relative velocity of b with respect to the other moving observer should be v1 plus c. But experiment shows it is equal to c. Speed of light is constant. Now this is absurd. Why this is absurd? Because this has traveled a distance v1, this has traveled a distance c. The distance between them has been reduced by v1 plus c. Then how is it possible that this person is also saying that his speed is c, while this static observer is saying this c, the moving observer is also saying c. C is not changing. This is just absurd. But this is what experiment tells us. So then came Einstein. He said that this can be explained by one way. Time is not universal. He said that when you are saying that this has traveled a distance v1 in 1 second, and this has traveled a distance v2 or c in 1 second, and you are asking what is the speed of b, that is how much it has traveled in 1 second with respect to this observer, how do you know 1 second of this observer and 1 second of this moving observer same? In other words, how do you know the clock in the hand of this observer and clock of this observer are running identically? Newton assumed all clocks run identically. So this is such an amazing statement that flow of time is relative. Time flows in one frame, time moving in another frame are different. Now this was really a revolution in our understanding of time. He said that flow of time depends on velocity. Suppose t0 is your time 1 second in that observer which was static. And suppose v is the velocity of another observer which is moving with velocity v with respect to this static observer. Then 1 second will now become t. T0 in his frame will become t, which is given by this, where you can see that since v square by c square is always less than 1. Of course, it is always less than 1. V is, suppose as long as v is less than c, and 1 minus something is less than 1. And square root of a fraction, so this is a fraction, 1 minus something, and square root of a fraction is very small number, it's a fraction. So t is greater than t0. In other words, 1 second has becomes 4 or 5 or 10 seconds in the other observer. That is, moving clock is running slow. In fact, if v is equal to c, then it becomes 1 minus 1, 0. T0 by 0 is infinity. So his 1 second has become infinite time. That is, his clock is not moving. The clock has stopped. So if something travels to the speed of light, clock has stopped. But so clock is moving slowly, therefore speed of light is not changing. So he showed it, Einstein. So try to understand the real revolution. It's a kind of completely changing our understanding of science. Such are the greatness of these discoverers. But this means that there is a limit of speed of everything, because since t is this, you have stated and you have proved that speed of light is constant. But if v is greater than c, what will happen? This is a 1 minus a quantity greater than 1. Then this quantity is negative, and negative of a square root of a negative quantity is imaginary. Time can become slow, but time cannot be imaginary. That's meaningless. What is the meaning of them? The time has loses meaning. So people asked Einstein that you have solved it, but you have landed up in a problem that if v is greater than c, then it's a dangerous situation. He said, Einstein was very smart. He said, nothing can move faster than light. The matter is closed. If nothing can move faster than light, then nothing will never be imaginary. But then people ask him, but why? Suppose you know force by mass is acceleration. You know, all of us know this, right? So if force by mass is acceleration, see this last equation at the end. If force by mass is acceleration, then if we apply force, it accelerates, speed increases, then finally reaches the speed of light and then exceeds the speed of light. What is stopping? If we keep on applying force and then body accelerates, and it accelerates, speed increases, and then one point its speed becomes greater than speed of light. How can you stop it? That nothing can move faster than light. What's the meaning of this statement? So Einstein was incredibly smart. He said, so as I said, speed increases finally should exceed speed of light. How can you stop it? It's a contradiction. Einstein said there is one way to solve it. Statement is mass is not constant. He said mass changes with velocity. So m0 is the mass when you are static, called rest mass. And if you are moving with velocity v, your mass increases because this quantity is less than 1. So I said anything divided by less than 1 is bigger. So mass increases when your velocity increases. When your velocity becomes c, what happens? Your mass becomes infinity because 1 minus 1 is 0. Velocity becomes c, mass becomes infinity. Mass becomes infinity means acceleration becomes f by infinity is 0. So acceleration stops, speed does not increase. So nothing can move faster than light because its mass becomes infinity at the speed of light. So speed is the maximum possible speed.
Hello, sir.
Tell me.
Here we use the midi light as the medium where we see. As the light reflects to our eyes, we can see it. So if there is any wave that have more speed than light, then we can use it there. So why the light is here?
No, but so let me tell you, the wave can only be created in two possible ways, right? One is electric and magnetic field, and that is light. It travels with speed of light. So light is electromagnetic wave. But how can you produce another wave? Tell me.
If we have the another media to get the information, more.
What do you mean by another media?
Anything, sir. I am not saying definitely anything. But
no, you have to say definitely something because you understand that what I am saying so far is I'm developing the subject logically the way Einstein did. You have to, if you want to say, you have to give example. There is no other way. You have only electric and magnetic field which travels with speed of light. And if any object tries to travel faster than speed of light, at speed of light, its mass becomes infinity. If its mass becomes infinity, it cannot accelerate because acceleration is forced by mass. The acceleration stops. So energy supplied by the force goes into, earlier we knew it goes into increase the kinetic energy, but now it increases the mass of the body, your energy. So you become fat when you move. So your energy supplied by the force goes into increase the mass of the body. In other words, energy is getting converted into mass. So Einstein was so smart, he immediately realized that if this is possible, then mass can be converted into energy. They must be equivalent. So work done by the force partly goes into increase the kinetic energy of the body as predicted by Newtonian mechanics. All of you have studied, you apply force, kinetic energy increases. But partly now goes into increasing the mass of the body as predicted by Einstein. So work done of energy is converted into mass. So mass is also convertible into energy. That
means number of molecules increase করছে.
No, not number of molecule increases. What happens? The mass, basically, suppose you take the same number of mass, but each molecule is mass, so each proton becomes more heavy. That's it. Not number of molecule increases. Each number of proton electron remains same, but they become individually more heavy. So when you say the mass of the electron is something into 10 to the power minus 28 gram, you don't remember, or 10 to the power minus 31 kg, the mass of the electron. It is the rest mass when the electron is at rest. But if the electron moves, it has a higher mass.
Okay, sir.
So energy and mass are interconvertible, and then from the previous few equations, you do a little algebra, nothing difficult. Do a little algebra, and you can come up with a famous equation, E equal to mc squared. That energy and mass are interconvertible. So from an energy divided by c square, which is very large, you can create small masses. All of you know that we create particle. How do you create particle? Higgs boson was discovered in Large Hadron Collider. How what was done? The huge energy was converted into a particle. So particle can be created, or a particle, small particle, can be destroyed, but it produces huge energy because the mass into c square, c is very large. So huge energy is created from a small mass. Small mass is created from a huge energy. So particle can be created, particle can be destroyed. Particle destroyed is atom bomb. All of you know this. Particle destroyed produces huge energy. You know the terrible thing that what happened. But of course, it produces a chance of energy creation. Particle created is that two beams, say Large Hadron Collider, they're hitting each other, producing new particles. So many particles, these are created. You know that you probably have heard that new particles are created. It's because of the Einstein same equation, that E from that huge energy divided by c square masses, small masses are created. So the new concept of time started, the new definition of time led to new concept of mass, energy, nuclear bomb, nuclear energy to solve energy crisis, creation and destruction of new particles, what not. And this subject, very briefly, what I've told you is called the special theory of relativity. Question is, consequence, when this was verified, tested, everybody believed, it tells nothing can move faster than speed of light in vacuum. But you remember Newton said gravitational effect propagates instantaneously with infinite speed. A complete clash. This contradicts Einstein's special relativity. In vacuum, no information can travel faster than light. So Newton and Einstein face to face. The conclusion, everybody believed relativity because it was tested so powerfully. People concluded something is wrong in Newtonian description of gravitation. So then came again Einstein, a revolutionary concept. Einstein rejected the Newtonian idea of gravitation, which you learned, two masses attract each other. He said this attractive gravitational force between two objects, two masses, is wrong. He came out with a brilliant idea. Let me tell you what is the idea. He said, consider a flat surface. When you draw a triangle, sum of the three angles of a triangle is 180 degrees. Take the shortest distance between 2 points, it is a straight line always. Take a circle which has a circumference 2 pi r. All of you have studied in your geometry class. It's called Euclidean Geometry, formulated by Euclid. But unfortunately, this is not true. None of these are true on a curved surface. On a curved surface, if you draw a triangle, the sum of the three angles are greater than 180. If the surface is convex, if the surface is concave, you know, in Bengali called Uttal and Avuttal, it's a concave, then it is less than 180. For flat, it is 180, what you have learned. If you consider shortest distance between 2 points on a sphere, there is no straight line. It is always a curved line. There is no straight line on the surface of a sphere. Similarly, no straight line on this, only on this. The shortest distance is a curved line. So he said that Newton thought a body travels along a straight line, Newton's first law, in absence of a force, and accelerates, that is, moves a curved line when there is a force. That is Newton's first law. All of you are learning it. So Newton said no force, something moving in a straight line, and something is, say, applying force, it is moving in a curved line, what Newton thought, the force between two masses and etc. Einstein said this thing is not attracting this by force of gravitation. And therefore it is moving in a curved line. No, it is not attracting this. There is no gravitational force between them. He said that this object have a mass which is changing the geometry of the space and time. And here the ball has no choice but to traveling in a curved line because the surface is curved. And seeing that it is moving in a curved surface, you are thinking that there is a force. There is no force. If the geometry bends, your motion has to bend, giving an illusion of acceleration. So you can imagine why people say that Einstein, one of the greatest of all time, just like Newton was, who formulated the fundamentals of science, and then came Einstein. Einstein said, force and geometry, strange idea. Presence of mass and energy, they are the same as I have explained, equal to mc square, curves the space-time. The shortest distance is now a curved line, giving an illusion of acceleration, and which we call gravitational force. Because there is an acceleration, Newton taught us from our class 3 that whenever there is an acceleration, there is a force. But no, it is accelerating, that is traveling in a curved line because of the space-time is curved. The illusion of force originates from curved geometry. So we say there is nothing, can you imagine the statement? There is nothing called gravitational force. It is a manifestation of space-time geometry. So to make it more clear that how do you understand, how do you measure it? So this so far we have given you by figures. So all of you know Pythagoras theorem, that hypotenuse square is perpendicular square plus base square. But do you know that this is only true in flat surface, which is called Euclidean surface? The geometry you have learned, you are using this so many times. But do you know what happens for a curved surface? A triangle is now looking like this. And this right angle triangle theorem becomes c square, hypotenuse square, is not 1 into a square plus 1 into b square. It is 1 plus some function of the coordinates of that surface into a square plus 1 plus some, suppose the coordinate of the surface is x and y, some coordinate. So these functions are coordinated b square. So this not c square is 1 into a square plus 1 into b square plus 1 plus something and 1 plus something. They actually determine whether the space is flat or curved. If f1, f2, 0, space is flat. If f1, f2, non-zero, space is curved. Now suppose you do in 3 dimension. I just talk about 2 dimension. In 3 dimension, all of you know the distance between 2 points x, y, z and x plus dx, y plus dy, z plus is what? This minus this whole square plus this minus this whole square plus this is the coordinate geometry you have learned. And distance square is dx square plus dy square. So this is a Pythagoras theorem in 3 dimension. The distance between 2 points is dx square plus dy square plus dz square from this point. But do you know this is true only for flat space? X2 minus x1 whole square plus y2 minus is a coordinate geometry. But this fails in curved space. In curved space, this d square is 1 plus some function dx square, 1 plus some function dy square, 1 plus some function dz square. These coefficients f1, f2, f3 are not 0. That is 1, 1, 1 will not be there if the space is curved. What happens now? Einstein told you that, see, apart from 3 space, you have now a time. So how do you define in 4-dimensional geometry? Just think 1 plus f1 dx square, 1 plus f2 dy square, 1 plus f3 dz square, and 1 plus f4. C square happens because the unit of distance and time are different, so multiply by c, this becomes unit of distance, and c is a constant. So what is important, that it is the generalization of my previous thing in a 4-dimensional space and time. It's a curved geometry if f1, f2, f3, f1 not 0. If they are 0, space is flat. But there is one difference, 1 plus this, but there is a minus. Why this minus? This Einstein showed that though now I have a space and a time also different, just as space were different for different observer, time is now also different. I have proved time is different, flowing differently. So I'm living in a 4-dimensional space-time. Now time is same for everybody. But time has one unique property. It can travel only in one direction. You can move towards future. You cannot go back to past. But in x, y, z, you can move to positive and negative both. So this minus sign actually guarantees that time you can move only in one direction, whereas x, y, z with plus sign you can move in both the directions. This coefficient has a mathematical name called metric. I define it by f. So these coefficients which measure the curvature. So you can see that they are, if they are 0, there is no curve. If they are non-zero, they are curved. So you see, you have now understanding mathematically what is the meaning of curvature. They are called the metric of the space, a technical name. These coefficients which measures the curvature can depend on time also. So now suppose the space is curved. I show you the picture of a curved space. But suppose this curvature is changing. It is now this curve, but then it becomes less, then it becomes large, then less. So this happening. How it will look like? See how it will look like. I'll show you a picture. This fluctuation, it produces this kind of oscillation of curvature of space. So this is a space where curvature is oscillating. And now see, it is looking like a wave. So this curvature can depend on time, leads to fluctuation in propagation of the space curvature like a wave. So this wave is called gravitational wave by Einstein. Gravitational wave is nothing but the curvature of the space which is oscillating. So take say a cloth, just at a couple now, take a cloth and just fluctuate. You'll see it is oscillating. A wave is generated on the surface. It's the same wave. So from the metric, those f1, f2, f3, f4, I don't want to see these details, but mathematical quantities are measured called curvature, or a mathematician Riemann formulated it, so called Riemannian geometry. If f1, f2, f3 all are 0, then the space is flat. We all know it's our Euclidean. But if they are non-zero, then you can measure how much it is curved, And Einstein wrote a famous equation, curvature in one side and mass energy in other side. If there is mass energy, it produces a curvature, and mass energy curves the space-time. Particle travels in a curved line, and we are imagining that there is a force. That is nothing called force. So this equation called Einstein's equation, which is though little more complicated looking, but I written in a symbolic way. This subject is called general theory of relativity. But now comes to our main question. Einstein said our space is like the surface of an ocean. সমুদ্রের মতো.
Sir,
Gravitational
one
wave.
question, please.
Yes.
R is equal to Km.
Hmm.
M means mass time, and what does
Mass and
K
energy,
mean?
right? So, right.
And
Yeah.
what does K mean?
Oh, so since unit of mass and is unit of mass as kilogram or gram, whatever. R is curvature, geometry. So their unit has to be matched, right? Both sides. So K is a constant which matches the geometry, which is actually related to the capital G Newton's constant, but it matches the geometry. Just as remember in Joule's law, you write W equal to JH. Why do you do that? H has a unit of heat, W has a unit of work. The Joule's constant J matches the unit. So K is something which is a proportionality constant which matches the unit in both sides.
Thank you, sir.
But later it was found that it was related to the Newton's constant. Einstein says our space is like the surface of an ocean, and gravitational wave is the wave on this ocean. As you can see that just curved the space, and this object has no way traveling in a curved line. So now how to test Einstein picture? So take the solar mass and put in Einstein's equation right hand side and calculate the curvature. Take the mass of the sun and solve the equation. Calculate curvature and find in that curvature, what is the path of a mass, which is the path. So that curved path, what is that curved path? So we take the path from planet and calculate its motion along that curved surface. Do you know the answer? You'll be surprised. So the answer is an ellipse. So this was a sensation in the whole world. We all know the path of the planets are ellipse. But then some people told Einstein, but see, even Newton could show that it is ellipse by putting his laws of gravitation in the right hand side and solving the equation. Newton also showed. What Newton showed by the using force of gravitation, you have replaced it by geometric curvature. So how do you know who is right? Both are giving the same result. So Einstein said that my thing is slightly different from Newton. According to Einstein, if this is the sun and this is the planet which is moving, after one full year when it travels full one thing, the next year the major axis of the ellipse is tilted in this direction. In the third year, it is the ellipse. In the fourth year, it is the ellipse. The major axis of the ellipse is gradually tilting. It is called perihelion precession. So Einstein, from his theory, and according to Newton, this path is ellipse, same ellipse. According to Newton, the path is same ellipse. According to Einstein, path is rotating ellipse. So now clearly the two theories and head-on collision. Einstein, from his calculation, showed that the rotation of this major axis is very small. It is only 0.01 degree in 100 years for planet Mercury, very small. And at that time, there was no such telescope to measure that. From Einstein theory, the angle of rotation for the planet Mercury is just 0.01 degree per 100 years. Few years later, telescope was discovered, an experiment was done. The result was 0.011 degree for planet Mercury. I tell you that I always say the headline of the newspaper next day was Nature Obeys Laws of Einstein. So this is an unbelievable discovery. Now, Einstein theory that met with hundreds of success when applied to astrophysics and cosmology. Einstein theory successfully explained many more phenomena, but I will tell only one more so that I can now finally get into my real topic. So you can see the amount of stage that is required with Einstein. So he also predicted what is called black hole. So what is a black hole? Black hole is a massive star which produces, the mass produces curvature. So because of the curvature, it collapses inside it. So its curvature is inward, so it collapses. And it collapses to such a dense object that it produces a strange condition called black hole. What is that? It produces strange condition black hole. It means when collapses to a very dense state, space-time around it become extremely curved. Because density, as mass and density increases, R, that is, remember, curvature increases. It is so curved that it's like a sink, deadly sink. Not even light can escape. See, here is a black hole. It produces curvature, and see the curvature is deadly here. So up to a distance, if something comes, it can escape back, go away. But if once it is inside this distance, it goes in. It's no even light, which is fastest moving. It goes in. It is called the horizon of the black hole. And horizon of the black hole, beyond everything goes inside and it looks black because nothing light cannot come out. So it's a deadly curvature. because of the huge density and mass. So this is finally a black hole has been photographed. You can see only just 2 years before, billion times heavier than Sun. It's called M87, which is named 55 million light years. Remember, 1 light year means distance traveled by light in 1 year, 55 million light years away. This black hole has been photographed. You can see the light is coming up to this point and then inside is black. Evidence of existence of black hole put Einstein theory on strong footing. Gravitational force is manifestation of curved geometry. Now the question, what happens to gravitational wave? Just as movement of electric charge produces electromagnetic wave, you remember, movement of mass should produce gravitational wave. So according to Einstein, this should happen. So from his theory, what he did, you remember this was the curved geometry, F1, F2, F3, F4. You put this into Einstein's equation. Do you know the equation that you get when you substitute this? Because that equation has F1, F2, F3, F4. The equation becomes, this F is either of F1, F2, F3, is this. You see, this is your old wave equation where speed is speed of light, not infinite. So nothing is violated. Gravitational wave also travel with speed of light, just as electromagnetic wave. So then came the mad search of this wave. Where is gravitational wave? Can we use this to talk with each other in mobile phone? Not electromagnetic wave. We won't need battery. Curvature can depend on time, leading to fluctuation of, as I said, propagation of space curvature like a wave. I have shown you that this picture I have shown you earlier. According to Einstein, movement of mass causes space-time curvature to fluctuate like the surface of an ocean, which travels like a wave at speed c, called gravitational wave. I show you the figure. As I say, I told you surface ocean, gravitational wave is the wave on this ocean. See, the masses are moving and space-time curvature because of their motion. It is moving, see, like a wave that you can see. The space-time curvature is traveling. This was his final dream. Remember, it was general relativity was proposed in 1915. But why did you have to wait 100 years, 2015? 100 years. Because it is very hard to detect. Unlike electromagnetic wave, it is very, very difficult to detect. Do you know why? I told you that Newton's constant is so weak. Therefore, when you are moving something, some mass, the gravitational effect is so small that it is oscillation cannot be detected. You don't have that instrument unless you can produce it by some huge massive object. That massive object can produce sufficient turbulence in the wave. So it is something like putting one leaf on the surface of an ocean. Nothing can be seen. But when a huge earthquake happens, there is tsunamis, the waves start traveling enormously. What is that tsunami producing event in the sky? It has to be very massive. So it is very weak unless a gigantic event happens. What gigantic event? In the sky, sometimes two black holes come close and collide with each other. You can imagine when two black holes of that mass collide, the amounts of turbulence that happens. And two black holes merge into a single black hole and release huge amount of energy in the form of gravitational wave. And that gravitational wave is substantial to be measured. But the problem with this thing is that we cannot, in like laboratory, we cannot ask two black holes that please collide and send me wave. It is not possible. So we have to create the instrument and wait. See, two black holes are coming. Since here the picture is two black holes are coming and colliding and producing huge gravitational wave which is going towards. And that gravitational wave reaches sometime us on Earth here, luckily. It may not reach Earth, but if it reaches Earth, then we will be able to detect it. To do that, the following instrument was created called LIGO, Laser Interferometer Gravitational Wave Observatory. This is a long tube of 4 kilometer length. Imagine 4 kilometer, and this is another long tube of 4 kilometer. Though
Professor Biru Rajo, it is not audible.
From my end, it is not. It is also not audible.
Okay. Should I contact speaker? Sir?
My end also.
interference. See, there is no gravitational wave here. So purely electromagnetic wave. It's products. So light rays reflected from two mirrors are superposed to produce interference. Result depends on the difference of path traveled by two rays. So see, all of you know this. This is a crest. This is a crest. If two crests of the wave meet, suppose you do a drop two stones in a pond. Waves are created, those waves are superposed. It can be sometimes dump the water. It's the constructive interference there in the same phase. And one is the upper and lower, just opposite phase, they destroy each other. There is the black. So you have seen interference oscillating bright and dark depending on the path difference. What happened? According to Einstein, this by each light ray will depend on curvature. Now, here is the whole catch. This light ray comes, this light ray comes, and suppose you create such a situation that their path difference is such when they are superposed here on the screen, their path difference is just opposite phase and they produce a dark band. It produces a dark band. Just opposite phase. So produces a dark band. Now, suppose it is like this, a gravitational wave arrives down. It arrives here. When it arrives, it has some energy. Energy changes the curvature. So the length of this tube and length of this tube will change. And since they are perpendicular, they will change differently. As a result, which was earlier a destructive interference, because of the change of the path length, they can now become a constructive interference.
Sir, one interruption. Sir, your voice is not properly audible. And কেটে যাচ্ছে আর স্যার মানে একটা স্লাইডে আটকে আছে হার্ড টু ডিটেক্ট স্লাইড কি শেয়ার করছে
নেট কানেকশন
So everyone is getting the same problem, sir. I think the problem is from your end.
You will left and then join. Try that.
Yeah, our most of the participants are facing the same problem, sir. I think the problem is from your end, sir. Could you please disconnect and rejoin?
Exactly so, Biru.
Yeah.
meeting ki
Your
day
voice is clear. But her voice is not coming properly. It's cracking.
No. Sir, I think sir has left the meeting and again he want to
Yes, Biru.
connect with.
মাঝের পরিমল ঘোষ বিরু।
হ্যাঁ স্যার আমি স্যারকে বললাম রিকানেক্ট করতে স্যার।
হ্যাঁ ঠিক বলেছো, ঠিক আছে।
হ্যাঁ স্যার করছেন, হ্যাঁ নেটওয়ার্কে মতলব ওনার এন্ডেই প্রবলেম, কেন কি আমাদের সবার প্রবলেম ফেস করছে এই প্রবলেমটাই স্যার।
মানে আমরা সবাই ওই স্লাইড থেকে গন্ডগোল করছি, খুব ভালো
হ্যাঁ আমি ভাবলাম 1-2 মিনিট একটু দেখিনি, লেকিন সবার প্রবলেম আমাকে চ্যাট বক্সে পার্সোনালি পিং করছিল। হ্যাঁ
থ্যাংক ইউ বিরু।
ওকে স্যার, থ্যাংক ইউ স্যার।
ব্যক্তিকে কল করে তিনি উত্তর দিচ্ছেন না।
বলছি স্যার আপনার না সিগন্যাল একটু উইক আসছে, সিগন্যাল এখানে শো করছে।
আমার সিগন্যাল উইক আসছে, ওদিকে আসছে, আপনার উইক না আমার উইক, আমি সেটা বুঝতে পারছি না।
না স্যার আমরা সব কমিউনিকেট করতে পারছি স্যার, আপনার সিগন্যালটা শো করছে এখানে স্যার, একটু আনস্টেবল সিগন্যাল আসছে। হ্যাঁ
হ্যালো কাকুলিদি, ওই স্যারকে আবার কল করো না।
হ্যাঁ
স্যারকে ফোন করেছি, স্যার কানেক্ট হয়েছেন, স্যার আবার ফোন জয়েন করছেন, স্যারের সিগন্যালটা আনস্টেবল শো করছে এখানে।
আচ্ছা আচ্ছা
কাকুলিদি একবার হ্যাঁ ফোন করতে পারেন, আবার ফোন করুন তো 1 মিনিট, আমি 2-3 মিনিট আগে ফোন করেছি।
Am I audible now?
Yes sir, audible.
Am I audible?
Yes sir, yes sir, audible.
আচ্ছা, কিন্তু
Now, sir, perfect, sir. Your video is perfect.
not perfect is, but somehow once again that shear problem has disappeared. I'm doing from some another.
ওনাকে প্রেজেন্টার করে দাও।
ना ना, एक मिनट, हाँ, एक मिनट सर, just hold. Sir,
এবার
now
প্রেজেন্ট
it's,
করুন স্যার।
হ্যাঁ, এবার করতে পারবেন স্যার।
করতে পারবো?
হ্যাঁ স্যার, প্রেজেন্টার করে দিয়েছি স্যার, করতে পারবেন।
Actually, এটা কি? Now see, let me tell you, this is another machine. I'm not doing from the previous machine was configured. আচ্ছা, আমি আরেকবার, just a minute, can you just do one thing? আমি আরেকবার ঢোকার চেষ্টা করছি।
হ্যাঁ স্যার, ঠিক স্যার।
Okay, just do one thing. Okay, please allow me to enter.
Yes sir, sure.
And now, okay, so I have entered another meeting.
Yes sir.
অডিও আসছে না।
স্যার স্লাইডও দেখা যাচ্ছে না, আপনার কথাও শুনতে পাচ্ছি না। হ্যাঁ স্যার। হ্যালো, হ্যালো। হ্যাঁ স্যার, শুনতে পাচ্ছেন স্যার? হ্যালো, হ্যালো। কেটে পড়ছে স্যার আবার, শুনতে পাচ্ছি না। শুনতে পাচ্ছেন স্যার আমার কথা? হ্যালো। হ্যাঁ স্যার, বলছি বলছি স্যার কি যে মাঝখানে যে সিস্টেমে গেছিলেন না, ওইখানে ঠিক ছিল স্যার। স্লাইডটা আমাদেরকে কাউকে দিয়ে দিলে আমরা নেক্সট করব। ওইখানে আপনার ভিডিওটা খুব ভালো আসছে স্যার। আর এখানে আসছে না, কিছু আসছে না, স্লাইডও দেখতে পাচ্ছি না। জাস্ট লেখা আছে সৌমিত্র সেন ইজ স্টার্টিং টু শেয়ার দ্য কন্টেন্ট, বাট স্টিল ইটস শোয়িং দ্য সেম থিং স্যার। আর আপনার যে আপনি যেখানে বসেছেন সেখানেও ভিডিও মাঝে মাঝে চলে যাচ্ছে স্যার। স্পিকার স্যার সঙ্গে কথা হয়েছে এক্ষুনি, মনে হয় ওনার ইন্টারনেট প্রবলেমে কিছু গন্ডগোল হচ্ছে, উনি মোবাইল হটস্পট দিয়ে কানেক্ট হচ্ছেন। কাইন্ডলি একটু ওয়েট করুন।
Can you hear now?
ইয়েস স্যার।
শেয়ার করতেন, শেয়ারটাতে কেন কাস্টমার starting to share content, but why isn't allowing me to share? Again, the same problem has happened. It is just not allowing me to share.
আরেকবার ওনাকে ইয়ে করে দাও, প্রেজেন্টার করে দাও। অন্য প্রেজেন্টার হয়ে গেছে, দুটো জয়েন আছে।
আর কে আছে একজন প্রেজেন্টার বলুন তো?
হ্যাঁ, ওনার নামে আরেকটা রয়েছে, সেটা প্রেজেন্টার হয়ে গেছে।
আচ্ছা,
হ্যাঁ, ঠিক আছে স্যার, এবার করুন।
Now it is all right. Now it is all right. Now you can see it, right?
yes sir, yes sir, yes sir, yes sir.
Okay. So I am entering that. Okay. Now everything is all right.
Yes sir.
Okay. So I'm just going. Okay.
Yes, sir.
Yes sir, yes.
Okay. Okay, fine. So as I said that the ideas from two are superposed to produce interference. one from this mirror and another from this mirror, they join here to produce interference, and result depend on the path difference, which I explained that it's a constructive interference, this is a destructive interference. And as I said, that suppose path length of the tube, so path length of the tube will change if a gravitational wave arrives and it curves the space. If the space is curved, then this path length will change. As you can see from this figure, that this, if the space is curved, then the path length will change like this. So as a result, which was earlier a constructive interference now can become destructive, which was earlier destructive can now become constructive. So space-time curvature changes when a gravitational wave arrives. This results into change of length of path traveled by light in each tube in the interferometer, leads to a change in interference pattern. So this is the whole idea. So you prepare the instrument and wait. Prepare the instrument and wait to see what happens. So we have prepared the instrument and we waited. And suppose the path difference was such that there's a destructive interference, and now there is a, so now there is, if the suddenly the path difference are different, then the crest and here the crest and trough, they destroyed each other, crest of the wave and trough of the wave. Now they are not destroying each other, they are slightly different, so you will see a resultant pattern like this. In United States, two LIGO was created. Two LIGO were created. One is these two tubes where light ray going this reflected, and interference pattern produced here, just as Michelson interferometer. And there is another here. I tell you why. One in Hanford, in the other is a Livingstone. Their distance is approximately 3,000 kilometers. Why two? Firstly, if it happens in one place, you may say there is change of path may have happened for other reasons, some local earthquake, some local effect. But if it is because of gravitational wave, then this gravitational wave will reach here and here both. It will reach the earth, that surface of the earth. So same thing will happen in both the places, both in Hanford and the Livingstone. See the intelligence. They have created two such instruments to check that it is not because of a local effect. And now see what happened. 14 September 2015, LIGO Livingstone data. A small fluctuation was there. This is because some small earth surface oscillation. Then suddenly they saw a big jump. So there was a destructive interference of laser between the two tubes. Now suddenly the interference pattern has changed. And when Livingstone reported this, after some time, Hanford said the same thing has happened with us also. So what they did, they measured the time difference of their measurement and their measurement. And their distance is 3,002 kilometers. So they divided 3,002 kilometers by this time difference. And it has been detected in both the places. And the distance is 3,000 kilometers. The time difference of detection confirmed that this distance by time is exactly the speed of light. So now it is proved. See the brilliance of the experiment. The brilliance of the experiment is the same wave has traveled from here to here at a speed. From here to here. Using the three-dimensional sky mapping, we found two black holes.
Audio
Measuring the energy of the wave. Audio disturb করছে? Can you tell me audio is all right?
হ্যাঁ স্যার একটু মাঝে মাঝে ডিস্টার্ব হচ্ছে স্যার, এখন ঠিক আছে স্যার।
Now it is audible, sir.
So using the 3D sky mapping, it was found by measuring the energy of the wave that two black holes of 30 solar mass rotating about each other eventually collided and merged into a single black hole. Do you know how many years before? 1.3 billion years ago. That is, the event happened 1.3 billion years ago, and we have detected it today because light has taken 1.3 billion this amount of light year to take the information to us. The resulting gravitational wave reaches us now after 1.3 billion years. So this was amazing. The two black holes collided 1.3 billion. Have you ever heard a sound, a music, which was sung 1.3 billion years before and which you are hearing now? LIGO US has shared their sound with us. I will play that sound and you will hear a sound, a song which was sung by Cosmos 1.3 billion years before, which has reached us now. So this is that wave, footprints of cosmic event. The resulting sound is the musical voice of the cosmos. So my last information, and then I will play the sound for you. Can we now hear the birth cry of the universe? By this I mean, I told you that galaxy was collection of many stars. Universe consists of many galaxies, and it is observed that distance among the galaxies are increasing with time. Universe is expanding. From Einstein theory, we get the same result. The universe is expanding from a point. So if you go back in time, it was just a point. An explosion happened 14 billion years before. 14 billion years before, everything was a point and it exploded. So universe consists of many galaxies, as I said. Distance between any two galaxies. I don't want to get into details of this equation, but remember that this is the density of the universe, pressure of the universe. Einstein's equation showed A is the distance between the galaxies. It showed that the universe, solving this equation, that the universe is expanding. It was shown by Hubble first experimentally. And so if you now go back in time, 14 billion years before, universe exploded. So this is the Big Bang. And energy released at the time of Big Bang gave birth to all the masses, atoms, molecules, everything from the equation E equal to mc squared. That energy of the Big Bang by c squared converted into mass. These masses are all the atoms and masses. So whatever you
what
see
is
around
Big
you,
Bang?
Big Bang is that point. Universe started, as I said, universe, all the galaxies are now, all galaxies are going away from each other. So if you now go back in past, that is past in time, you will see that 14 billion years before, all the galaxies and everything was there at a point. And that point, there was an explosion, and that explosion caused release of huge energy. And because of the explosion, just as the splinter of a bomb spreads, the galaxies are spreading away from each other. And that explosion is called Big Bang, which happened 14 billion years before. Now,
why this happened?
Nobody knows.
Why this explosion happened?
Why this has happened? The statement is nobody knows why this has happened. Most important, nobody knows who gave that energy, and from that energy, all the masses were created. And that mass is all the masses of atoms and molecules that you see, and that is considered our life. So we are all children of Big Bang. But we do not know why it has happened. We do not know who gave that energy. And we do not know what was before that. That is the beginning of existence. So science meets philosophy there. The Big Bang is the beginning of our knowledge. Now, at the time of, and now, with the Big Bang happened, it was prediction that still a heat wave, because of the expansion, temperature has fallen, but 3 degree Kelvin heat wave should be there in every part of the universe, because it's there at the time of the Big Bang. So there is no reason it will be in Calcutta, but not in Bombay or not in New York. Penzias and Wilson in 1965 detected that radiation is uniformly distributed to the whole universe and temperature is exactly 3 degrees Kelvin. It is actually 2.7. Big Bang theory was established by this detection. Both of them got Nobel Prize. So this is the Big Bang. See, gradually universe expanded and things formed, various structure formed. And that radiation filling all over the universe has been detected. But as I said, what happened before, we do not know. This was the beginning of time. The universe rapidly expanded with all the mass and energy. So according to Einstein, accelerating mass and energy caused gravitational wave. It is called the primordial, that is the time of the birth of the universe. It's the birth cry of the universe. The universe went through a huge explosion in inflation. It's called expansion, very fast expansion. And that such accelerated expansion gives rise to gravitational wave called primordial gravitational wave. See, I will show you a picture that Big Bang happened and see this gravitational wave, which should be there still now. Still the print of that should be there. We are desperately trying to detect that gravitational wave. What we have detected is a collision of black holes. But what we are trying to do is this. Can we detect this primordial gravitational wave created at the initial epoch to hear the birth cry of our universe? This is our next search. But to conclude, a new era of communication, gravitational wave, or new mode of communication is finally established. Emergence of a new era. Gravitational wave spectroscopy, not the electromagnetic wave spectroscopy. We have measured the collision of two black holes by gravitational wave, not by light. So, well, can you talk over mobile phone? A mobile phone cannot be size of a black hole, but you know technology develops. When Michael Faraday and Benjamin Franklin discovered electricity, could anyone imagine that today the entire modern civilization will stand on this? We do not know where this discovery will lead us. But definitely now we have another mode of communication, gravitational wave. I will play that sound for you, which LIGO India has sent us. Just be with me. You will hear two sounds. One is loud, and the other is, the first there will be some small noise, and then the living stone, and then the hand for two sounds. You will see the sound of that song of the cosmos. So I'll play now the song of the cosmos. Please let me know whether you can hear this. Can you hear this? Sure. Remember, you will first always there's a background noise, then suddenly the Hanford and then the Livingstone, two sounds come. These are the sound or song that was sung 1.7 billion years before. You are hearing that original sound. I am playing it again. So could you hear it? Could all of you hear it? The sound?
Sir?
Yes.
How capture the sound?
How? Hello? What is the question?
How capture the sound?
So they receive the gravitational wave. I have shown you that they receive the wave. Here is the two waves. So moment they received the wave, this has an energy, right? So that energy was converted into sound. How do you think that sound is produced in your loudspeaker? The sound is produced by when the energy fluctuation happens, this oscillation, this frequency is converted into the sound wave and you hear the sound. So this is the Livingstone sound, this is the Hanford sound that you have heard, the two sounds.
Sir, will you please play once more, because
Sure. I'm playing once more. So could you hear it? I'm trying to play it once more in a big speaker and let me know that whether it is better. Please wait. Listen. Is it okay? Could you hear it?
No, sir.
You couldn't hear it?
No, sir.
You couldn't hear it. Okay, let me play again. Please listen carefully. Please listen carefully. Can you hear the sound now? Yes or no?
No, sir. No, sir. Sir, if you allow, sir, if you send me, I will send it to a WhatsApp group, sir.
I cannot share the LIGO
Okay, sir.
sound.
Okay, sir. Okay, sir. Okay, sir. It's okay, sir.
The slides are fine, but these are, these
Okay,
are
sir.
LIGO.
Not an issue, sir. Okay, sir. Thank you, sir.
Here, you can't hear anything?
স্যার শোনা যায়নি
শোনা যায়নি, কেউ শুনতে পায়নি?
And a little bit of beeping is there.
No, sir. previous যে ফার্স্ট বার প্লে করেছিলেন সেই সময় একটু হালকা হালকা করে ফাট করে দুবার আওয়াজ পেলাম স্যার, আর এইবার তো কিচ্ছু পেলাম না স্যার।
তাইলে একটা বিপিং আওয়াজ পেলাম।
কেন আমার কথা শুনতে পাচ্ছ, দিকে সাউন্ডটা শুনতে পাচ্ছ না কেন বলো তুমি? দাও একবার।
স্যার এইটাতে ফিল্টার লাগানো আছে সিসকো ওয়েবেক্স এ, আপনার সাউন্ডই শুধু আসছে, বাইরের সাউন্ডটা নয়েজ রিডাকশন জন্য ওটা নয়েজ হিসাবে ট্রিট করে নিচ্ছে, ওকে ফিল্টার করে দিচ্ছে।
আচ্ছা, নয়েজ বলে ফিল্টার করে দিচ্ছে।
নয়েজ হিসাবে ট্রিট করছে, ফিল্টার করে দিয়েছে, সেই জন্য শুনতে পাচ্ছি না আমরা।
Okay, let me see if I can send. Okay, I'm trying to send the file to you. Okay, so that you can have it. Okay, I'll take some permission for that. Okay.
Oh, okay, sir. Okay, definitely.
Okay. So now, let me just conclude by showing you the last slide. That is the. So we've heard the sound which was produced so many years before, but most important, this is a final success after 100 years, and maybe some of you, our younger generation, is waiting to do a fantastic technological discovery of this discovered fundamental science. Finally, gravitational wave, the only other wave, electromagnetic wave we knew for so many 100 years. Now we know a new, you understand now the real excitement. Another mode of communication, gravitational wave detected finally after 100 years. So it's a great discovery, but most important thing I can tell you, in the coming 50 or 100 years, the research will be dominated by this area. And let me tell you, India government has donated several hundred crores, and the LIGO India is being created. They are very close friend of mine. We have done a lot of work on gravitational waves in our institute. So they are building it up. In fact, I have a plan to go there. And it is being located in near Maharashtra. and it will start operating tentatively from 2024-25. Now the tunnels are being created. The appearance is same as we have seen in Hanford and Livingstone. So we are hoping that there will be huge excitement when LIGO India will start operating, and many researchers will join, and this is going to be a phenomenal area of research in the coming days. A new mode of communication, gravitational waves. Okay, thank you all of thanks to all of you.
I have a question.
Yes, please go ahead.
Sir, you said gravitational wave is a propagation of curvature of space, just
That's
like
right.
ripple in a pond.
Right.
Can you hear me, sir?
Yes, I can.
So can we say that space is something realistic which may have elastic property?
Well, no. So you have to understand that when I say curvature, I'm not saying that space has a material content. No. But the space itself is a very mysterious thing. That space is given by some geometry. Now,
You can't hear anything. I think Sarah is muted.
So, but it looks like, I agree, it looks like a kind of elastic nature, right? So it's an elastic nature of vacuum. If you accept it, then it's fine.
Sir, will you please repeat again your answer? Actually, I cannot hear you properly.
Okay, so what I'm saying that this is curvature of vacuum, not of any medium. Okay, so this is curvature of pure vacuum. So vacuum curvature is something which is we are talking about. So there is no matter in space. But elastic property always we associate some matter. So there is no matter. But it is very hard to understand. It is truly an elastic nature of vacuum. Okay. So could you hear? Yeah, could you hear what I've said?
Yeah,
okay.
Yes, sir.
Okay. Yes.
Sir, would you please explain how we expect communication using gravitational waves over modes which are using now? What are the relative advantage or merits or demerits, however it may be? Could you please explain? Of the communication modes using gravitational waves.
Okay,
what are the
so
expected
okay, I understand. Okay, so first thing is that this is generated by pure mass and energy. We don't need any electric charge for this. We do not need any battery or electric source for this. Second, it is the being curvature of space-time. The black hole which absorbs even light. Some phenomenon which you are observing at the level of collision of black hole can only be understood by gravitational wave. This cannot be understood by light. It is expected that this geometric oscillation of geometry, possibility to element. So far it is more observation. I agree. But it may be someday very useful for Earth observation because we do not need any electrical source for this.
Yes, sir. But
Okay.
how much time we have to wait?
Okay, so it is difficult. So if you imagine when, how much time it took, almost 200 years, close to 150, 200 years. But I now expect that much of time will not be needed, because you know that this is not linear. So earlier at that time, which took 150 years for electricity magnetism theory fully developed.
Yes, sir.
Here, because of the huge development of our technology and science, maybe this time it will be 50 years.
Okay, sir. Thank you, sir. Let's hope so.
Yeah, sure.
Sir.
Thank you very much, sir.
Yes.
Sir, I have a question, sir.
Tell me.
Sir, you told that the gravitational force is instantaneous. So, to travel the information between two masses.
According to
we
Newton,
don't-
not
Newton.
Einstein changed that, right? Yeah.
But sir, the similar problem arises in Coulomb's law, na?
Yeah, sure. Yes. So yeah, they are very right. So Coulomb's law, when see, the thing is that in Coulomb's law there is certain subtlety which you have to understand. That when Coulomb's law, suppose you have two electric charges separated by distance r. So Coulomb's law looks like this, but do you know that you have a relativistic formulation of electricity magnetism? So electricity magnetism has a very inherent property which was later shown by Lorentz and Einstein. It's a good question. That electricity magnetism to start with is such that by suitably incorporating magnetism, and you have seen that both magnetic field and electric field, they are integrated by the electromagnetic equations later by Maxwell. So Coulomb's law is just some static charge. So for some static charge, there is no question of moving, so there is no question of wave. But movement immediately brings in magnetism. And that takes care of the new field equation for electricity magnetism, which is perfectly consistent, where you will find that it travels with speed of light. So Coulomb's law, there is no motion, there is no wave at all. But moment you move a charge, you immediately go from electrostatics to bring in magnetism. And moment you bring in magnetism to see the wave, you will see that everything is fine. But for Newton's law of gravitation, there being only one kind of mass, there is no positive, negative mass, one kind of mass, such a thing does not happen. So for Newton's law, even if the mass moves, no other new field appears and make it relativistically consistent. So the problem is there more. So, okay, it's a good question. So moment you do it go beyond electricity to generate wave, magnetism takes care of this, your question.
So sir, two forces, electrostatics force and the magnetic force, are originated from actually one
Same
property of
electric charge.
matter.
One property electric, exactly. That's right, exactly. Which constitute electromagnetic wave, not electric field alone. So moment that two comes together, then everything is consistent. It becomes finite.
Sir, I have another question. Can I ask?
Yes. Yes, sure.
Sir, here we relate the gravitational force with the geometry of the space and time,
Right.
space-time, right? So you also tell that for acceleration we have to curve our path, not we cannot move in a straight line. Sir, can we relate the curvature of space-time with any kind of force? That means I want to tell that.
Okay, I
can
understand.
we geometrize the electromagnetic force or the strong force or the weak force?
Okay. Again, a good question. Einstein exactly tried to do that, not with other force, but only with electromagnetism. In the last 26 years of his life, remember, he tried to get electricity magnetism from geometry, but he failed. He wrote a paper called Unified Field Theory, but that was wrong. Much later, and in an alternative way, two scientists, Kaluza and Klein, they showed that you can get your electricity magnetism from geometry, but if you assume that apart from these three space, you have an extra space. That's a very strange concept. You have an extra space.
Sir, four space. the extra space is
Alexander,
beyond the four space. That means x, y, z, t.
is three-dimensional space. About this is four space, a new space, right, new direction. So later, but so things they showed a way, but people challenged them that what is the meaning of this? We have never seen any another space, another direction. So nothing happened. Then much later in 1980s, a subject came called string theory, which picked up that concept again, and that showed that not only electricity, magnetism, but all the other forces, strong, weak, everything, that you can have a geometric interpretation. And they said there is not only one extra space, but there are 6 extra space. But they and why only 3 are visible, the 3 space that we see, and why the other extra 6 space become invisible by a technique called compactification. So these are some details which I can, a separate talk I can say one day. It's called theory of extra dimension. So now what question you are asking? Yes, we have a resolution of the other forces through geometry, and that the geometry is not of these 3-dimensional geometry, but geometry of some hidden space that we cannot see.
Okay, sir.
Is
Thank
it
you,
all
sir.
right?
Thank you very much.
Okay. So any other?
Sir, I have a question.
Yes.
So we have heard different types of sounds of different planets. So how can we get the sounds?
What do you mean by different?
Different planets.
I mean, exactly what the planets have their own, there are certain planets on which there are huge storms are happening, right? Wind flow is happening because planets are moving around the sun, right? And therefore there is each planet have their own atmosphere, and that has a storm which has a sound, right? Because of the motion of the atmosphere of the planet. Otherwise, the planets have no intrinsic sound.
Okay, sir. Thank you.
Okay.
Thank you, sir, for such a wonderful talk.
Okay. Thank you
And
from my
all
part
of
also.
us here. Thank you, sir. And words did not fail to have a positive impact on all the students present here, and will surely be instrumental in creating news and right in them
Okay,
for
thank you.
all their future.
I
I
just
also
request.
hope that it will. Yes, sir.
Yes, please go ahead. I was saying that if you can share my email address to them. If they have any questions, I can always try to answer. Okay.
Yes, sir. I also hope that it will help the students to further have this topic for their higher studies. Now, with due permission from all the respected members present here, I would like to ask Meenakshi Di, Dr. Meenakshi Chakraborty, to continue for the vote of thanks. Thank you.
Good evening, everyone presented in this webinar. Honorable Speaker, Professor Soumitra Sengupta, respected Vice Principal Dr. Sandip Bhattok, and all these participants. It is such an honor for me to get the opportunity to thank you all the dignitaries. At first, I would like to convey special thanks on behalf of Physics Department to Dr. Sandip Bhattok, our respected Vice Principal, for providing immense support and constant encouragement for organizing this webinar. I extend my sincere gratitude and thanks to the Honorable Speaker, Professor Soumitra Sengupta, for delivering such an interesting and valuable talk. which has really entitled us in the area of gravitational wave and cosmology, which is related to 2017 Nobel Prize. I convey my thanks to Dr. Kakuli Bandyopadhyay, Coordinator, Department of Physics, to organize such an wonderful webinar amidst of this pandemic situation. I thank to Coordinator IQAC Dr. Samuel Sheth for the collaborative support of IQAC for organizing the webinar. I also must thank to the members of organizing committee along with technical team, Dr. Biru Rajak, Dr. Pradeep Bhatti, and Mr. Subhashish Ghosh for their technical support to arrange the webinar. At last, but not least, I must thank to the participant of the webinar, as without their active participation, this kind of event cannot achieve the grand success. Thank you all.
Okay, thank you, everybody.
And sir, it will be very grateful if you give your PowerPoint presentation so that our student and we can enlighten more.
I will send this to the, you have your, I have your email. So have you sent me your email?
Yes, sir. I have sent it.
You sent it, right?
I have sent a letter, invitation letter from my side.
Okay, fine. I will send it there. Sure. No, absolutely. I'll do that.
And sir, some relevant papers of yours so that we can read it and
Relevant
also
paper. Okay,
get
fine.
some.
I will write in the email. I will write in the email. Sure.
Okay. Thank you, sir. Thank you very much.
Thank you. Thank all of you.
Thank you, sir. Thanks a lot, sir.
Thank you.
Thanks a lot, sir.
Thank you.